welcome to another GCSE revision video, and this video we're going to be introducing the concept of circles. If we take a straight line and fix one of the ends of the straight line and then rotate the straight line around that fixed point, the shape that was drawn is a circle. It's one of the properties of a circle that every single point on the edge of a circle is exactly the same distance from the centre of the circle. A line going from one side of a circle to another side of a circle is known as a chord. Any line from any point on the edge of the circle to any other point on the edge of the circle is known as a chord. If the chord goes from one edge of the circle to the opposite edge of the circle, going through the centre of the circle, then that chord has a special name called the diameter. It is the longest possible chord that you can get. The length of the diameter is what is generally accepted as the width of the entire circle. Now the distance all the way round the outer edge of the circle is called the circumference of the circle. If you divide the circumference by the diameter of any circle, you will get the mathematical constant pi, by which I mean if you divide any circumference by the diameter of the same circle, then you will get the mathematical constant known as pi. No matter how big or small your circle, if you divide the distance all the way around the outside of the circle by the largest possible straight line that can be drawn from one end of the circle to the opposite end of the circle going through the centre of the circle, then the number you come up with will always be the same, and it will always be this mathematical constant that seems to crop up a lot in maths called pi. Pi is the ratio of the circumference to the diameter of any circle. The letter pi is from the Greek alphabet, and it's the Greek letter P. It is the first letter of the Greek word perimetros, meaning circumference, but from which we get the English word perimeter. The value of pi is impossible to express accurately, but it is approximately 3.1416. But to three significant figures, this can be approximated to 22/7 or 3 1/7. Now before we go on talking about circles, I do want to give a word of warning here. Pi is not the same as 22/7. Pi cannot be expressed exactly, but it is roughly 3.14159265 and the digits go on forever. Whereas 22/7 is roughly 3.14285714 and the digits go on forever. But as you can see, they are only approximately the same when you get to the second decimal place. So they're both roughly 3.14, but the numbers get very different after the 3.14. So if you're going to do calculations up to 3 significant figures, it is perfectly okay for you to use 22/7 as a substitute for pi. But if you need your answer to be more accurate than 3 significant figures, you cannot use 22/7 as a substitute for pi. Now the digits in pi do indeed go on forever, but that does not mean that pi is infinity. Pi is most definitely not infinity. Infinity can be described as the biggest number you can possibly think of is too small. However big a number you can think of, there is always a bigger number. But that is not the definition of pi. Pi is not the biggest number you can possibly think of, or even bigger. I can very easily think of a number that is bigger than pi, and that number is 4. In fact, pi is bigger than 3 and smaller than 4. So it is definitely not infinitely big. It's not even infinitely small. There is a number lower than pi and there is a number bigger than pi. So pi comes on the number line somewhere between 3 and 4. Now if we want, we can zoom in on this number line and magnify it by a factor of 10, and now we can say with 10 times more accuracy that pi is somewhere between 3.1 and 3.2. Pi is definitely bigger than 3.1 and it is definitely smaller than 3.2. And if we wanted to zoom in again, so we magnify the number line by a factor of 10 again, that means we are now 100 times more accurate than we were when we said pi is somewhere between 3 and 4. We can say pi is definitely bigger than 3.14 and it is definitely smaller than 3.15. In fact, we could go on zooming in to the number line for as many times as we want. No matter how much we zoom in, we will never ever get an exact value for pi. Not only is it impossible to find a decimal number that will exactly represent pi, but it is also impossible to find a fraction in the form of a over b, where a and b are both whole numbers. So we say that pi is irrational, but pi is certainly not infinite. Okay, getting back to our circles, the distance from the centre of a circle to the outer edge, or the circumference, is called the radius of the circle. Any line going from the centre of the circle to the outer edge is called the radius. And every radius of the same circle is exactly the same length. Which means the radius must be exactly half of the length of the diameter. Or, put it another way, the diameter is exactly twice the length of the radius. Now if you take the circumference of the circle and divide that by the diameter, you will get pi. So if you take the radius of the circle and double it to get the diameter and then multiply that by pi, you will get the distance around the edge, or the circumference of the circle. Or, to put it more simply, if the radius of a circle is r, then the circumference of the circle is 2 pi r. If you can excuse the somewhat circular reasoning. Now at GCSE level you are only expected to know that the area of the circle is pi r squared. You are not expected to justify or to explain why the area of a circle is pi r squared. Now if you're anything like me, you hate taking other people's word for it. You really like to see some kind of proof. Unfortunately, every proof that I can find is beyond or involves a level of mathematics that goes beyond the scope of GCSE level maths. However, if you're feeling brave and you really want to know why the area of a circle is pi r squared, stand by for the next video. If it hasn't already been uploaded, feel free to subscribe to my channel and you'll be notified when it is uploaded. Otherwise, look out for the very next video. But I warn you, it does involve a level of maths that goes a little beyond the scope of GCSE level maths. So we're straying into A-level maths territory here. Okay, if you liked this video or found it helpful, don't forget to like, comment and subscribe. If you're taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in another video.